So we're given an equation here. On this equation, on letter A, they say they find the equation of a tangent line on this curve at the point 1 and negative 2. So we know we must first find the gradient, which means we are having y squared, which is equal to x cubed plus 3x squared, which means what I will do is to introduce a d over dx, both side d over dx. So on the left hand side I will have y equal to 2, then dy over dx, which is equal to, on the right hand side I will have 3x squared plus 6x. So I will divide both sides by 2y. I will have my dy over dx, which is equal to 3x squared plus 6x divided by 2y, which is equal to, I have to substitute back the values of x and y. I have 3, the value of x is 1 there because the point is 1 and negative 2, which means I have 1 squared plus 6 into 1 divided by 2 into negative 2. So which means the gradient m will be equal to what? 3 plus 6 divided by negative 4. 3 plus 6 is the same as 9, negative 9 over 4. That's my gradient. So which means I will have y equal to mx plus c, which is the straight line of a what? The straight line of a tangent line, that is the gradient of that, plus c. Now, since I have this, I have to find what? I have to find the value of what? The value of c. How can I find the value of c? By plugging in these values there, the value of x and y. So I will have negative 2, which is equal to negative 9 over 4, my x, which is 1, plus 6, which means 6 equal to what? C equal to negative 2 plus the 9 over 4, which means from there I will have what? I will have a negative 2 plus 9 over 4, which is 0.5, which is, that is 1 over 4. So which means the tangent line is negative 9 over 4 x plus 1 over 4. That's the tangent line. Then moving forward, the question says at one point that the curve has a horizontal tangent. Remember that thing is a cubic, ne? A cubic can go like this. So they are asking at one point that thing has a what? Has a horizontal line. Horizontal line normally is here and also here. So basically they are just saying what are the values of x here. Remember, there is at what? Here is at maximum point and here is at minimum point. And we're given the equation as y squared, which is equal to what? Let me double check. X cubed plus 3x squared. So how can I find they are looking for what? For the values, what points? Okay, they are looking for the value of x and y. So from there, I know that at this point, at the maximum and minimum point, my gradient is equal to what? Is equal to 0. Understand? So I will just take this thing from where? I will just take it from here. That's where I will take my thing, because already I have derived that thing. So after I derive the thing, I have 3y dy over dx, which is equal to what? 3x squared plus 3x. Then I know my gradient is equal to what? Is equal to 0, which means I will substitute my 0 here. I say equal to 3x squared plus 3x, meaning that 3x squared plus 3x is equal to what? Is equal to 0, which means when I remove common factor of 3, I will remain with x squared plus x, which is equal to 0. Then I do what? I remove common factor of x. I have x plus 1 equal to 0, meaning the value of x equal to 0 or x equal to negative 1. So I have to substitute those points where? On the original equation. or anywhere. I can substitute them on original equation, which means I will have what? I will have the so-called I will have y squared equal to x cubed plus 3x squared, which means from here I have the value of x as equal to 0. I have the value of x as equal to -1. So I'm going to substitute the value of what? The value of 0 this side plus 3, the value of 0 this side, which means I will have y squared, which is equal to 0, which means the point on this side is 0 and 0. Then this side I will have y squared, which is equal to what? -1 cube plus 3 into -1 squared, which means my y squared will be equal to -1 plus 3, which is equal to 2, which means the answer will be plus or minus square root of 2, which means the second point will be what? Will be -1 and -√2, and then the third point will be -1 and +√2. That's how you will give them the points.